Hello there. So here we are asked to determine the output voltage of this circuit, that is V out. So we are given a voltage source V plus, and we have this resistor R that draws the current I from the supply, and then we have put up this Zener diode, which has a manufacturer number IN751A. So it has a forward voltage, not the forward, reverse voltage breakdown voltage, VZ of 5.1 volt. That means if the voltage at this node with respect to ground exceeds this VZ 5.1 volt, then the zener will enter into the conduction. As we know from the IV characteristics of the zener, we see that for the zener diode, for the reverse applied voltage, the current through the zener is negligible, but as soon as the applied voltage in a reverse way exceeds the zener breakdown voltage VZ, which is given in the data sheet specification, there is a sudden conduction current that flows through the zener, and that current is called as IZ of the Zener diode. Okay, so that's the reverse. In a forward bias mode, Zener works as a normal diode with a breakdown voltage in a forward volt is about 0.7 volt. And here the VZ for this particular diode is rated as 5.1 volt. So what we can do, we can apply the, and when it enters into the conduction, this I equal to IZ, okay? Neglecting the current going at the output, because the output is not connected to the load. It is open circuit voltage. So we don't have any current flowing into this branch, rather I equal to IZ. And then we apply the KVL in this loop. We apply the KVL in this loop right here, which tells us the equation V plus minus IR minus VZ is equal to 0 for the given values of V plus about 12 volt and VZ is 5.1 volt. We can get the drop across the resistor R, which is IR, and that drop you see here, which is V plus minus VZ is equal to 12 minus 5.1, it is 6.9 volt. And for a given value of a resistor required current, we made sure that the IZ is also specified in the data sheet, and the current flowing through the diode in actual circuit doesn't exceed its maximum rating IZ, because IZ max into VZ max is the PD Z max, that is the power dissipation into the Zener diode. So for a R value of 1K, if for example, we will not be given the R value, rather we will be given a required current value. Okay, how much current you want for the load, for example. And according to it, we have to choose the resistance value. But for now, here I'm using R equal to 1K and I equal to IZ because the Zener is into the conduction in the reverse bias mode. Therefore, the value of the current through the resistor and through the zener will be 6.9 milliampere. So this is how we can design a simple references using the zener and the resistor. So right here, the value of your V out will be 5.1 volt is equal to 5.1 volt, which is the zener voltage drop. This is the zener voltage drop of 5.1 volt. Okay. And what is the drop across the IR? This is 12 minus 5.1, which is 6.9. Okay, so you just learned how to analyze this circuit using resistor and the zener, and how zener can be used to generate the output references. Remember, this reference is not yet analyzed for its temperature dependence, load variations, and the supply variations. That is an exercise for you.